Hi there, I'm Tammy, and today we're going to be talking about black holes. An exploration of black holes, strange failure modes. I'm Tammy Bryant Butow, and I'm an SRE at Gremlin. You can also find me on Twitter. My handle is at Tam Bryant Butow. Let's get started. Everything has its wonders, even darkness and silence. I really love this quote. It definitely means a lot when you think about distributed systems. So think about all the things that happen which we don't expect, which are strange, which are unusual. Maybe a service disappears. Maybe suddenly a region disappears. Maybe something goes away for a few milliseconds. Maybe it's gone for hours. Something that we think about is maybe it's gone into a black hole. So when you think about a black hole, you might think of something that looks a bit like this. Somewhere where if anything goes into it, it's going to just disappear. So today we're going to explore strange failure modes that are unexpected and surprising. What is a black hole? A region of a distributed system where gravity is so strong that nothing, no requests or transactions, can escape from it. All IP packets in this region are unable to escape. How can we actually create a black hole? Well, we can capture IP packets at the transport layer, targeted by supplied port and host arguments. We can use existing traffic policing features in the Linux kernel to drop targeted IP packets. I actually think it looks a little bit like this. Say you're on an e-commerce store, an online shopping store. You try and find the product catalog item that you like. You reach out for it. Suddenly it's not returned. It doesn't appear. Or maybe you add something to your cart, then you go to grab it to check out and it's just not there. It's vanished. So what happens when your banking transactions are in a black hole? This is something that I've definitely seen happen in the past because I worked at the National Australia Bank for 6 years. When I was working at the National Australia Bank, I saw all sorts of different things that could go on with banking transactions. A lot of the time, there's nothing actually bad happening to the person's bank account or their banking data, but it's what's being actually shown to them on the front end. For example, what if your balance is displayed incorrectly? Or what if it displays as $0 even though you've actually got money in your account? Or what happens if you tried to put $1,000 into your account and it doesn't actually show up? That's also not good. Then you're going to get really worried. Or what happens if you put in $20 in your account and suddenly there's a duplicate transaction and you actually get 40? That's also something that I've seen happen. There are a lot of different errors that can occur related to banking. So what we're going to do to learn more about black holes, how we can experience them and how we can create them, is we'll be using this architecture of our banking application, which is an open source banking application called Bank of Anthos. And you can find this on Google Cloud Platform's GitHub. So check that out here. The really cool thing about this online sample bank is you can create users. It comes with a test user. You can log in. You can then see your transaction history, see the amount of money in your account. You can make deposits. You can send payments to people that are already loaded in as contacts. And the other really cool thing is you can just click this button here, open in Google Cloud Shell, and that will create an environment for you to do your chaos engineering experiments and work for free using Minikube and Google Cloud Shell. So let's check that out. This is what it looks like when you've logged into Bank of Anthos. You can see here the current balance. You can also see that you can deposit funds, you can send payments, and you can see the transaction history. Let's click Open in Cloud, Google Cloud Shell. So the first thing it's going to ask you is, would you like to clone this repo? Let's click Confirm. Now it's going to provision your Cloud Shell machine, connect to your Cloud Shell instance, clone the remote repository, and then open up the Cloud Shell editor for you to be able to see the workspace and interact with it. So now in Google Cloud Shell, it says here that we could use Minikube or GKE. So let's use Minikube. We're going to first click on Minikube down the bottom here, and then this is going to actually allow us to start a Minikube cluster. So let's click Start there. You can see now everything is loading up. We're starting up Minikube. So the next thing we need to do is deploy our JWT token because Bank of Anthos uses a JWT token for user account creation and authentication. To do that, we're going to click on the YAML file link just here. This opens up this file. Next, we want to click on Open Terminal. A quick and easy way to be able to apply this is to just use kubectl apply and apply that file. So that's going to enable us to be able to get started. All right. You can see here that JWT token was deployed. Alrighty, let's click Next. Now we want to run on Kubernetes. So to do this, we can actually click on the Cloud Code menu. That's just here. And then we want to click Run on Kubernetes. Let's click Default as it says. And then click Yes to keep the context. And then click Authorize. Alrighty, so now everything has been built and deployed. Next we're going to actually go and log into the banking application. So what we need to do is change our port to 4503. So we're just going to grab that. Click Web Preview, change port, paste that in, then click Change and Preview. Now you can see here we've loaded up the banking application and it has a test user that we can log in as. You can see here we've already got a current balance of just over $7,000. We can deposit funds, so let's try that out. And we can also send payments to friends. So let's send Eve $100. And you can see that that shows up here in our transaction history. Cool. So the other thing is we can also add new recipients if we want to send money to different people, and we can also add new external accounts. And we can sign out, and then we can also create additional users if we want to build them bank accounts as well. So all in all, that is what our setup looks like. Something else we will look at is, let's check out what we've got running here. So we'll run kubectl get pods, and we'll see here these are all of the pods that are currently running to make sure that our application works. The other thing we'll want to do so that we can start practicing some chaos engineering on this demo application is to install Gremlin using the Helm chart. So we'll just make sure that Gremlin's already there, the Helm repo. Next we'll create a namespace for Gremlin. And then last up, what we want to do is we want to log into Gremlin. So if you go to gremlin.com/buttons, you'll actually see this page and you can create a Gremlin account for free to get started and try it out. Once you're logged in, go over to your team settings and then click on configuration. And you'll see here, this is where you get your team ID. You'll get a team secret. Just click to create one or reset it. And now what we can do is we can actually install Gremlin via the Helm chart. So if you check out here, you'll be able to see how to do that. So this is what we need to run, and just replace your team ID, your cluster ID, your team secret, and your cluster ID can be whatever you would want it to be. I'm going to just make my cluster ID bank. This will allow it to show up within Gremlin as bank. Cool. So I've deployed Gremlin as well to my cluster. So that all looks really good. Next up, what we want to do is check that Gremlin is now showing up as one of our clients. So let's click over on clients here, and you can see that yes, it is showing up, everything works well, and I can now attack Minikube, which is being run via Cloud Shell from Google Cloud. All right. So now let's also check out what we can do. If we click on infrastructure, and we can see here, this is our one Minikube host. But not only that, there's actually 35 containers that have been created based on that sample application. And then also, if we click on Kubernetes, we'll be able to see all of the deployments that exist from the banking application. And let's look at these here. So balance reader, Chow is actually Gremlin, contacts, core DNS, front end, ledger writer, load generator, transaction history, and user service. So now we're ready to actually run black hole attacks on these different deployments within Kubernetes. So for example, transaction history is running one pod right now to enable our Bank of Anthos to be able to display the transaction history. Alrighty. Cool, so we learned a lot more about our application by actually spinning it up and checking out what pods are running, both using kubectl and also looking from within Gremlin in the visualization view. So a good question to ask ourselves is, does blackholing a critical path service like the balance reader result in graceful degradation of the customer experience? So we would assume that balance reader would show this balance here. And from looking in Gremlin, if we select just the balance reader, you can see here that there's one pod, one replica set, one deployment. So if we make that one balance reader pod unavailable, we assume that we won't be able to see the balance anymore within our application. So let's see what happens. We'll select balance reader. We'll then black hole it, and we'll see that actually the balance appears to be dash dash dash, which could actually make the user think that they have no money in their account. So they might start to get worried, ring up, call everyone on the phone, send tweets about this, send in customer support tickets. A lot of people would really worry if they saw this. But can we make deposits? Yes. The user would still be able to make a deposit of $1,000 while the balance reader service is in a black hole. It just wouldn't show that the balance has actually changed, but you would see that the balance down here actually is showing up as $1,000 added. But we wouldn't be able to send payments. We would actually get an error, and it would say payment failed, IO error on GET request for balance reader, connection refused, because currently we've made sure to apply and put the balance reader service into a black hole. Everything has its wonders, even darkness and silence. We learn a lot there that we didn't know before about our application. If you'd like to create this free demo environment yourself, just click on the link to install the banking sample app with Minikube on Google Cloud Shell. Click to start Minikube up, apply the JWT secret YAML file, then click on Cloud Code, run on Kubernetes, and change the port to 4503. Then install Gremlin so that you can create your own black holes. Create a namespace for Gremlin and install Gremlin as a Helm chart. Let's look at something else now. Let's see how a black hole impacts our transaction history service. So this is what our transaction history service does. It displays this information here. So the date, the type, credit or debit, the account number, the label, and the amount. So what will happen? Will we have a graceful degradation of the customer experience when we make transaction history unavailable? So what we end up getting is an error message. Error, could not load transactions. So this is what would be displayed to the user if that transaction history is not available because it's been black holed. What can we do to mitigate against a black hole like this? Well, depending on the service, scaling replicas may work well. So we can actually use Kubernetes scale deployment functionality and say, give the transaction history deployment 2 replicas. So dash dash replicas equals 2. After that, you'll see here that we actually have two pods running called transaction history, which is slightly different because they're two separate pods. So what we have here, now updated architecture diagram, is that our deployment set for transaction history actually has two pods now, pod 1 and pod 2, which both contain all of the data required to be able to display the transaction history information. So what will happen now? Well, there will be a very short outage, very, very short, and then the other pod will take over. So you will still see the transaction history, and you won't actually experience a large outage and not be able to see your transaction history. It'll automatically work. How awesome is that? So we're still able to see transaction history, we don't get any more error messages, and everything just works well for us. So now let's look at a different sample example. What happens when part of an online store is in a black hole? So this is our architecture here, and what we're going to do is we're going to run a black hole on a service called the ads service, which you can see up on the left. We're going to make it that ads disappear into a black hole. They're unreachable, we can't find them, we can't use them anymore. Goodbye, ads. So here's what our ads look like at the start. Advertisement, city bike for sale, 10% off. So I'm highlighting that there just so you can see it. Now I'm going to select the ad service. So what do we think is going to happen? When we black hole a non-critical path service like the ad service, will we get a graceful degradation of the customer experience? Yeah, we do. Awesome. So actually the page gets a little bit smaller, the ads disappear, everything works as expected. So that's awesome. This is awesome, graceful degradation. Our experiment was successful, and our results here are what we expected them to be. The black hole did not negatively impact the customer experience or our overall SLOs, for example, for purchases. What are the different sizes of black holes that we can experience or create? There are a number of different sizes. When creating black holes, start micro and then gradually expand the blast radius. Micro, stellar, supermassive. These are all different sizes of black holes. If you think of something really small, it could be just one pod. So let's say just target one pod. If we want to think of something a little bit bigger, we can then think of, let's take down a whole service, let's take down several services, and even bigger, let's take down a whole region and see what happens then. Do we gracefully fail over? Does everything still work as expected? A few other questions to think through are, how do black holes impact observability? Do we know when a service is unreachable? Do we see this change our data available in our dashboards, monitoring, observability tooling? How about our logs? Can we see that request times are going up because we're not able to actually reach that service? Are we seeing a rise in errors? What's happening? What can we learn from black hole related failures? If we think back to the examples that we looked at, we saw that we could make deposits, but we couldn't actually send money to anybody else. We could not see our balance. It was showing as 3 dashes instead of telling us there was an error, which maybe makes us think that we have no money in our account, which could make people really worry. Or, for example, we could think about, hey, maybe we can use Kubernetes built-in scaling functionalities to scale out and just make sure that we have more pods available. How can we use black holes to learn how to make our systems more reliable? If you think about using black holes for a region failover, this is the best example. So for example, you can make a region unavailable for something as small as 60 seconds. Imagine that, being able to test region failover in a minute, being able to make sure that you know if everything's working well, and then being able to get out of it. So just saying, let's make it unavailable, now it's back again. That's much better than tearing down an entire region and having to pull it all back up again. When we think through our reliability plan of doing this work, I recommend starting with, obviously, a lot of the work is going to be your tactics. What are the specific experiments that we're going to run? Next up is your strategic goals. What are you trying to get and learn from these experiments? Then is our mission, our overall vision, and our values as a team and an organization. The online banking application that we use today can be found on the Google Cloud Platform GitHub, Bank of Anthos. And also you can get this book, If you go to gremlin.com/talk/blackholes, you'll be able to grab a copy of a book that I wrote called Reducing MTTD for High Severity Incidents. Thank you so much. You can find me on Twitter, Tammy Bryant Butow. Thanks so much. Bye.